Hi there, it's Fred and Fred. Thanks for tuning in to Guitar Media, and welcome to Guitar Media's Fender Blackface Reverb Repair and Cascade mod video. We're here today to take a look at this 1965 Fender Pro Reverb. Okay, safety first. We definitely do not want to get electrocuted. You need to be very careful if you're going to be working on the amp when it's on, and make sure to use something that's wood or definitely a non-conductive, because there is potentially over 400 volts under the hood here, and so let's just stay safe. Okay, welcome to our local disaster space. As you can see, we have the reverb amp completely taken apart, as well as the reverb tank over there to our right. So first things first, this is V1, this is V2, this is V3. V3 is our reverb driver tube. They call for a 12 AT7 on the tube chart. This is our reverb driver transformer. And this is our reverb recovery tube, and they call for a 7025 in this position. Okay, so the next thing I recommend checking out is you can pull your tank out, and you can pull the bottom off the tank and then turn it upside down and take a look in here, and what you'll see is this housing here actually is on these springs, so it can move a little bit, as you can see there, and that can cause these small green and black wires to come loose. I've had that happen a couple of times, and sometimes, you know, this little winding here can also have an open in it. Okay, so now let's check the tank and see if it's any good. We'll pull the cables off the back here and start with the reverb output. Okay, as you can see, we've got about 216 ohms from checking from hot to ground on the reverb output, and then checking from hot to ground on the input. I will select on the 2000 ohm selection for the output. I'm going to select the 200 ohm selection now for the input, and as you can see from hot to ground there, I've got 1.7 on the input. And another thing, if you don't get a reading there, what you can do, your actual cable might be bad, and what you can do is you can put one lead on the hot on this end of the cable, and then have the other lead on the hot on the other end of the cable, and then you should get a continuity check there. And then you can do the same thing with the ground. You can put one lead on the ground on this end of the cable, and then one lead on the ground on the other end, and that should give you a continuity check. And of course you would check both ends. And another thing, if you check from hot to hot, you shouldn't get anything. And what we're checking here from hot to ground is actually these little guys right here. Let's see if I get my camera to focus. It's these little mini transformers, this yellow thing here. So that's where we're getting the reading from, and there's one on each end there, in the input and the output. quick, the reverb input, it says here reverb input. There's nothing tricky about this. Input goes to input. That is on the tank. It also has an input. So input goes to input and output goes to output. It says output here and also says output on the tank. See if I can get that. I'm not sure if I can get it. Nah, I don't. I'm sorry, you're not going to be able to see that on camera. Okay, so if you've checked your tubes, you checked your wires that go to the reverb tank and the reverb tank, and you're pretty sure it's not the tubes, the wires, the reverb tank, the next thing I do is pull the chassis out and very carefully get a pencil or a some sort of wooden stick, and I start tapping around very carefully with the amp on, with the volume up a little bit and the reverb up a little bit, and just to see if I hear a crackling. And I'm looking for a sign that maybe there's a loose solder joint or maybe a loose resistor, a cold solder joint here or there. And this can cause the reverb to not work. So conveniently or inconveniently, I've actually had this problem in the past, and I actually bought a replacement transformer, reverb driver transformer, and after installing it in the amp, it turns out it wasn't the transformer. So it turns out it was a resistor or one of these connections at the transformer. So anyways, bottom line, I had an extra good transformer laying around. So what I did is I laid it up on top of the chassis, like as you can see here, and this is actually the old bad driver transformer. And what I did is I disconnected one wire at a time under here and reconnected the reverb driver and checked it to see if that fixed it, and of course it did. And the symptoms in this amp were you could turn the reverb on 10 and it could be heard very low but just not right. And so after I found out that was it, I actually took a marker, and I don't know if you can see it or not, but I marked the positions here with like a color coding so that I knew where all the wires go when I went to rewire my reverb driver transformer. more good thing to check here is this V3, let's see. V3 actually goes to ground here. Let's see, I'm going to zoom in. So V3 actually goes to ground here, and this actually goes to here, and it goes to ground here, and you can see this other ground wire over here, and that's V4, the reverb. So the reverb driver ground is here and the reverb recovery ground is here, and you want to check down here. Let's see, there's a brass plate down here, and sometimes these can come loose, and this can cause a problem with and possibly make the reverb not work. And so that's also another good place to check for a loose solder joint down here. Okay, so another good thing to check here is you can see this is our reverb knob here. So the reverb knob is got a pop back here, and that's the reverb potentiometer right there. And so you want to check the solder joints there, and also just see sometimes the shaft can be loose in the pot, and sometimes the pot can be just a bad pot. So sometimes this will actually just need to be replaced. And let's see. One more thing here with the amp on, you can set your meter to direct current, the direct current setting, and you can put one leg of the meter here on the chassis, and then at every little resistor V here on the other side, you should be getting a plate voltage of roughly 130, and that's another thing you can check. And if you don't get, like if you get 0 right here with the amp on, and you're obviously going to you should get your voltage here, but one of these resistors can actually potentially have an open, and that could also cause your reverb not to work, and probably a lot of other things too. I guess that about wraps it up for the reverb repair section of this video. I hope this has been helpful, and I hope you have been successful in getting your reverb functioning. Totally worth it. Such a great reverb and a classic Fender Blackface amp. Okay, so this amp without the modification, the normal channel and the vibrato channel are running parallel into the phase inverter section of the amp. For the non-modded or clean recordings, we plug straight into vibrato input 1, which works completely as intended. It's not been modified in any way. And we turn the volume on 10, we run the treble on 10, and we run the bass on 10. Now, occasionally using a little reverb. Now for the Cascade mod recordings, we plug the guitar straight into the normal channel input 1, and we actually use a jumper cable on the vibrato channel. And what this does is effectively lifts the signal from ground, increasing the gain even more. Typically we run the volume up into the point where the guitar becomes microphonic, and then we'll back off it a little bit on the volume, which is usually rather high, between 6 and 7. On some guitars we are able to turn it all the way up. We typically run the treble all the way down, but on some guitars we'll sort of dial it up just a little bit into the point of microphonics and then back it off. And the same for the bass. There's just so much gain that by leaving the treble and bass off, we're actually effectively driving the mid-range frequencies, which just typically works better and is more responsive for highly overdriven and distorted type tones. and it also helps to smooth out the tone a little bit. Here on the controls for the vibrato channel, we do the same thing. We leave the treble down and the bass down, and sometimes we do, you know, put them up just a little bit until the point of microphonics, and then we'll back it off just a little bit so we're not dealing with microphonics sounds. Okay, so as quickly as possible, just my understanding of the circuit of the amp. The guitar comes in to input 1 here, so it pretty much is going to go straight to your V1, and V1 has 2 gain stages. So it's going to come out of gain stage 1 into these 3 capacitors you see here, and this is the tone stack for the normal channel. And it's coming out of that gain stage into the tone stack, and actually your plate voltage is coming in here, and what these capacitors do is actually blocks that plate voltage so that the DC line level signal, as it travels into your treble and bass controls and volume controls, there's no voltage. So it's about 130 volts on the plates back here. These capacitors block that voltage. It's only 200 or 300 millivolts here at this end of these capacitors, and so the signal flows into your potentiometers here. So now that the signal's at the potentiometers, it actually leaves the volume control, effectively coming directly into gain stage 2 on V1, and coming out of gain stage 2 on V1 into the plate voltage area here. Once again, there's this capacitor, and then it leaves this capacitor in with the millivolts, 200 or 300 millivolts, 130 volts plate voltage back here. This capacitor blocks that voltage, 200, 300 millivolts here, and it sends this signal all the way to this end of the amp, and this is where it was actually going to the phase inverter at this position here, into the phase inverter, and that's it. That's the normal channel. And so those 2 gain stages, and then the phase inverter creates another gain stages, so a total of 3 gain stages for the normal channel on this amp without a modification. Okay, so we're going to go to the back of the amp now, and I've turned around, and we start out zoomed out here so you can kind of see where we are in the amp. So now that the signal is here at the phase inverter section, what we're going to do is, see, this resistor was actually connected here at this point with this ceramic disc capacitor and this other 220k ohm resistor, and that is the the vibrato and reverb channel. So it was connected in parallel here going into the phase inverter. Now we have lifted this leg of the resistor and we have turned this resistor around and connected this white wire. So the signal of the normal channel is now going into the volume pot over here, and you can see the white wire going into the far right terminal on the volume input. And the signal coming out of the volume on the center tap here is actually going into the bright switch. And so coming out of the bright switch, you can see this green wire is also connected here at this terminal, coming out of the bright switch into, see, I'm moving the camera so you can see it, this resistor here. So what we've done here is we've actually lifted this leg of the resistor that was connected before to the bottom of the low sensitivity input jack terminal. It's at the bottom. It's kind of hard to see way down there at the bottom. But now we've lifted that resistor away from that position and got it out here in the open and connected this green wire. So now our signal is actually coming from the normal channel into the vibrato and reverb channel. And so we've effectively cascaded the signal and added 2 gain stages in the process to this. And actually from this view, you can see how this jack actually lifts the ground here. It's very interesting. Okay, once again, we're going to start zoomed out so you can see where we are here. So now we're going to focus on these 2 wires here. And these 2 wires here are actually, you can see that they're soldered together at this position. And what this was is this wire here on this side was actually connected, or the white wire is now connected. That was previously coming into the volume off of gain stage 1. And this wire on the other side that is now connected here was actually connected where the green wire is now connected. And that was coming out of the volume control into the bright switch and out of the bright switch into gain stage 2 over here. So the reason why we've had to solder these together is now that we have the input to the volume and the output to the volume soldered together right here, what this has done is deleted the volume position. The volume control is now deleted and the signal is allowed to pass through as if the volume was on 10 and completely lifted away from ground. And the reason why we've done this is because in between gain stage 1 and 2 is not a good place for this volume to be, because this would leave, see, normally when this volume is on 10 going in parallel to the phase inverter, the noise is not that loud, like a subtle shh. But then when you add 2 extra gain stages to the normal and vibrato channel, now all of a sudden the white noise has been amplified by maybe possibly even 5 more gain stages, or at least 3 or 4 more. And so now the shh is very loud shh. And so that's why we've moved this, that's why we've done this and moved this position of this volume. So now when the Cascade channel is not in use, we can effectively turn gain stage 2 down here, and by turning it down we lose all the noise, so we're not dealing with any noise when we plug straight into the reverb and vibrato channel. Well, other than what would normally be here, which is not bad. Okay, we're going to start zoomed out again so you can see where we are in the amp. And so unfortunately what has happened here is on the schematic, the bass capacitor, which is the very first one right here, this white one, they call for a 0.1. Well, what we have found here is that we've accidentally created a tremolo circuit. And so basically what would happen here is, as I would turn the bass on 10 and lift the signal from ground, we would get this tremolo effect, which is really not what we want. So what we've done is, by changing the value of this capacitor from a 0.1 to a 0.01, we've effectively eliminated the problem, and also arguably changed the bass control into what is now more of a mid-range control. And so now, if we can turn the bass on 10 if we want to, it's not an issue. And we can turn the treble on 10 too, as long as the guitar is not microphonic. And another thing we've done is this amplifier calls for a 70-25 in V1 in the first preamp 2 position. we've changed it to a 12AX7 because as we find the 12AX7 to be more high gain than the 7025, we have also found the 12AX7 to be less microphonic. So the guitars we use for the reverb section of this video include the 2020 Squire Classic Vibe Thinline Telecaster, the 2024 Squire Classic Vibe Jazzmaster in Sonic Blue, and the 2024 Made in China BB King Lucile Commemorative Edition. The guitars we use for the Cascade mod recordings include the 1996 Made in USA Stratocaster, the Telecaster Parts Caster with the Joe Strummer pickups, the 2024 BB King Made in China commemorative model, as well as the 2024 Les Paul Custom Made in China, which we also waxed the pickups and did an out-of-phase mod on. just one more thing I wanted to mention here is these capacitors. This capacitor, on the schematic, it calls for a 0.022, and whoever has repaired this amp before we got it, replaced this capacitor with a 0.039, which is almost double the value, and this actually goes to the ground on the bass control on the normal channel. And so far we haven't experienced any issues with that, and we're not sure if we want to change this to a 0.022. We haven't decided. But another one here in the mixer stage also, if my memory serves me, called for a 0.022. This is also a 0.039, so that's also double, and could play a role in a slightly different sound in this amplifier than other Pro Reverb amplifiers. And we've also noticed they did the same thing here on the normal and vibrato channel, and what calls for a 0.022 capacitor on the bass side of the tone stack going to ground. We also see another 0.039. And I didn't notice any other faulty values throughout the amplifier, but I did want to mention these. For the reverb recordings, we plugged the amp into the 1969 C12M Chrome Dome, and that is the speaker we're miking up. Our close microphone at 24 inches is the Sennheiser E835, and the room microphone is the Nady RSM4 ribbon microphone. For the Cascade mod recordings, we plugged the amp into the 1969 Celestion T1217s and using the same microphones. On some of the recordings, we used the Boss RT20 rotary ensemble. We use also the Jim Dunlop original Crybaby, as well as the Worm by Electro Harmonics 24-volt modulation effect, and even the Korg AX100G for some tremolo effects. around these cascade modifications to really bring out the flavor of the gain structure of the amplifier and sort of reveal its own thumbprint, if you will, and its unique sound and overdrive tonal characteristics. And I think it's worth noting that when you increase the gain and increase the gain stages, a lot of times really we get like just a lot more mid-range and a lot more bass. And this is something that may make you want to consider some sort of a high-pass filter system. And what I mean by this is, like, say, for example, humbuckers sometimes can become too bassy and there's just too much sag in the bottom, can become mushy and muddy, and we don't want that. So a good high-pass filter would be like a Telecaster, for example, just a much thinner sounding guitar, something that has a lot less bass. And that's really just an example, because like, say, with a Les Paul, you could easily incorporate the use of out of phase, which is also very effective and relieving some of the bass frequencies. And this is something I think you should consider if you're adding one or more gain stages to an already full and round sounding tube amplifier. If you'd like to support the channel or see some of our videos ranking higher in the Google and YouTube search engines, please like, comment, and subscribe, as this is absolutely free and the best way to support the channel. Thanks for watching, and check our channel for our latest videos.